what I'm doing is I'm looking at this from somebody who's going to mark it from an LEP point, all right, in the LEP. So some of the things that Gordon did have wrong, which now we have corrected. Things, for example, he had 32 amps on these two of the breakers here, because when he looked at cable C9, he was looking at 2 amps per point. He had 8 power points, 8 doubles, and it made it 32 amps. We looked at it and it said non-domestic. It was just an incorrection of reading, so we brought it back to 1 amp. That means so that he's now got these all corrected here. The other thing we had over here was, this was another 32 as well. That came back to a 16. And I think, what else was there, Gordon?
Yes.
Oh, the earth didn't have a cable tie in it either. So what I'm going to do is walk through the things that we're going to have a look at. I'll get Gordon with his paperwork in a minute as well, if you could grab your paperwork, Gordon. So the first thing we're going to look for is make sure that the cables in the pit are labelled with the street address. Do we all agree? All right, so any pit you do, they need to know what the street address or a lot number as well. If you're in a new estate and they don't have house numbers, it has to have the lot number on it. Okay, so he's got that. You don't necessarily, you will have a cable tie supplied. Most of the time you're only going to have 2 cable ties supplied, and that will be for to hold the cables. Now, notice the cables in these 2 points here. This is where the meter goes. So the meter goes over the top of the cable tie. Does that make sense? I need to be able to pull this out too without having an obstruction. Okay, so you're going to have a cable tie there to make sure the cables are tied up. We're also going to have another cable down here on the main earth. Now, the main earth has his label. He's obviously got a handwritten label, but this is one of the ones that you would buy. Do not disconnect. Now, in the LEP, you're not going to have pliers. So the earth has to go down through the wire where it's crimped. Now, one of the other guys had it where it was sitting on the other side. It must go down and it must come past, all right? You don't strip it back and then loop it up. That's what you would normally do in a domestic situation. But here you don't have any pliers available. Do you understand what I'm getting at? So you need to make sure the insulation comes down. The cable tie on there must be on the top or made in a position so it cannot be pulled off. Do we all agree with that? All right? The next thing we're going to look at is, we come back to here, we've got all these. We need to make sure that we have the line side and the load side. Do you understand what I'm getting at? There's no use me having line, load, load. Do you understand what I'm getting at? It's got to be line, 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 load, load, load on the bottom. I can't also have 2 in the top either. I need to have one, it doesn't matter which way they go, but I need to have one in the top or either side and one in the bottom because they actually bridge out on the top. Does that make sense? So I do need to have them opposite. You can have them in the 2 in the same side, it doesn't matter. All right, they're both the same on that point. These are made that if you had to double them up or put extra holes in there, it doesn't matter. But the 2 on the bottom of the load, 2 on the top are the line side. All right, they come in, this tail here. Now we're looking at the moment, I'll have a look at this, he's put his diagram up here, I'll just move this up further for a sec. This diagram is supplied. Where do I find that? We find that in the SIR book, all right, Service Installation Rules. They have all the stuff about wiring up switchboards. Anyway, you can see where the mains come in the top, line into the top, load on the bottom, we come out, and we come out with our meters. The minimum size for our neutral here is 4 or 6 mil, all right? We don't need to put a thick, heavy 25 mil wire on the bottom, all right? All it's doing is putting a feed to supply a voltage feed into the kilowatt hour meter, all right? Because you've got voltage and it's got to be able to measure current and voltage, all right? So we have our 4 mil coming here correctly, all right? The other thing we need to do now is make sure he's got his labelling, do not remove. It's got the street address, it's got a plan of where the mains are, telling me the size of the mains coming in, 6 mil, explained as on the project, telling me all the information that I need. Up in the top corner here too, he's put main earth electrode, right, located below panel, all right? That needs to be in there. That's a wiring requirement as well. And I'll show you that on the visual defects one where it's actually located. So that needs to be labelled in there. The street address he's put on here is not a requirement because we have the street address on the front of this cabinet. Do you understand what I'm getting at? This can be taken off and moved. The meter panel is always here to stay. Do you understand what I'm getting at? All right, plus we have other labelling. So you can put it on there, but you're not going to get extra marks or anything for it. They're looking for it mostly on this one here. We all agree? Yep, good. The other thing, so main switch, light and power. Because it only has one main switch, you can call it just main switch. All right, if we have two main switches on the board here, for example, I had a main switch down here for the hot water service, this would then have to say main switch, light and power, main switch, hot water. Does that make sense? All right, if you had a different feed or something coming into it. All right, he's labelled the switchboard. Also, we make sure that we have all our pockets covered up, whatever. All right, you can't just stick a little bit of card. I mean, normally we had to have all our plastic covers over the top. We've got our, make sure we've got our labelling, 3-phase power, stove, power, and going down. All right, can I get you to remove the panel for a sec, buddy? So while he's removing the power, the thing I'll be looking underneath is looking at the maximum demand and making sure that the circuits align across the 3 phases and make sure we've got the correct amount of neutrals and the correct amount of earths. All right, so he's going to label that up the top. He's going to take the other one off. Now the thing we need to look at while he's looking at the switchboard is I'm going to make sure we've got the correct number of circuits, which we're going to match to the project. We had, now the only thing that the assignment didn't say is how the cables are run. All right, the one we did have a bit of a discrepancy that we won't with Steve because it didn't say how it was run was, for example, the stove, right, up the top here, we looked at it as in 2.5. But if it was partially surrounded, and that's if that was told us in the description, the 2.5 wouldn't pass. Now we looked up in the 3008 book, table 10, right, and it said a 2.5 is adequate for a stove of 9 kilowatt with 25 amps, all right? If we went to partially surrounded, the cable failed and we needed to put in a 4 mil, all right? They didn't have that in the description. That's something you need to make sure you understand when the LEP comes, if they've told you how the cables are run. Do you understand what I'm getting at? All right? Because that will make a difference between you using all the same cables and how you will work out the sizing of cables. So that means that we would then have to go to a blue cable. All good? So what's happened now is we've got our cables coming in. We make sure and what we did do is we had a look at his maximum demand. On the very end here, he's put the size of the circuit breakers and the size of the cable. And then what I've done is I've gone down and I've had a check. So for example, the white one here, the lighting circuit, is on the lighting down here, is on number 3. All right, and we had that coming off the number 3, which is 1.5. But we went through, checked to make sure that all the circuits were on the respective phases, as the load's been done on here. You understand what I'm getting at? I also went through, this has also got a link up the top here. I also made sure that the earth, the main earth here, had 2 screws on it, up the top here, so it's in the first one. The bonding earth then goes into the second one, and then all the earths. Now the earths, it doesn't matter which order they go in, but it's preferable to put the earths in line, because if you look in the wiring rules, they normally like to have the earths and the neutrals and actives line up with each other. Do you understand what I'm getting at? All right. So we look in here. So that, for example, this one here on the last one coming through would match in. So this would disappear up into the subboard, and the same with the last one. So it's important that all these line up in correct order. All right. We've done that. We've checked. I've counted up 7 earths, 7 neutrals. All right. We've made sure that I've got all the wires. There's no exposed. There shall be no exposed copper. Any exposed copper underneath, you'll lose marks on straight away. All right. We come over here. The wires from the top of the main RCD need to be run to the top of the isolator. All right. You can't leave short tails for it. Okay. So you bring your tails out. That's the only thing on the 3-phase. The cables must come to the top of the isolator here. The earth and the neutral is done as well. Over here, he's run over here. The top, this main switch, this can be an isolator. Now, what we talked about when I was with Gordon and that before is that if it's protected over here by a circuit breaker, right? How do I determine the size of the circuit breaker protecting the mains? Is based on maximum demand. Okay? We put a 16 over here. We come over here. Most of the time, people will put in a circuit breaker as well. Do you understand what I'm getting at? And pretty hard really to buy an isolator these days. So we'll put in, it's pretty much double protected. I can't put a 16 there. I could put a 32 there, but it's not appropriately protecting the cable. Do you understand what I'm getting at? All right. these two here combined came to 13 amps we looked at, all right, which was our maximum demand. Our circuit breaker cannot be less, or the main switch coming in on that there, cannot be less than the 2 maximum demand combined on this board. I've got 2 RCDs, I've got 2 earths, 2 neutrals, all right? They're both labelled 16, all right? And AON10 for the lighting, okay? Other things I'm looking for is, we've also done the main earth here. Would I need to put a tag on there if it was a strip earth? No. The strip earth comes from here straight through down to the ground. It's actually in 25mm cable. There's no tag requiring it because I can't mechanically or physically remove it, all right? And it goes through on the ground, all right? You will probably get more strip earth writing and things for visual faults, but not so much on the wiring side. All right, is there any other issues I've missed on there, do you reckon? No? Making sure all our pockets are covered, everything's labelled correctly. But you will lose marks, as I said, if things aren't labelled correctly or we don't have things done. As I said, we get 2 cable ties. We get one for here and we get one to put on the earth, all right? And you'll also find with your wire that they will give you the correct amount of wiring. There won't be anything to go to the rack and pull off wire. They will give you all the lengths of cable and everything, and it'll be the correct value. So if you muck up on your maximum demand and put something the wrong way, you'll soon know down the track. So that's why you need to make sure you've got all your prep set out first, all right? And work out where you're going. All good? All right, thanks very much. We'll walk through